All right, you've seen this thing, right? This metal box just hanging out on the side of a bulldozer or an excavator. You've probably walked past 1,000 of them. But have you ever really stopped to think about what's inside? Because I can tell you, this is no ordinary box. This is the hydraulic tank, and honestly, it's one of the most critical and, I think, most cleverly designed parts in all of heavy machinery. It's a real unsung hero. Now, it's easy to look at that and think, oh, that's just the fuel tank. But nope, not even close. This box holds the lifeblood of the machine's muscle. We're talking about the hydraulic fluid. And the real secret here, the thing that unlocks all that power, isn't just that it holds the fluid, but how it holds it. The way this thing is designed is what lets a machine lift a multi-ton bucket or turn with pinpoint precision. The engineering inside the simple-looking box is, well, it's surprisingly elegant. So first things first, we gotta get this idea out of our heads that it's just a simple box. It's so much more than a storage vessel. I mean, engineers spend a ton of time just on the design, thinking about the type, the size, even the exact location on the machine. And trust me, there's a really good reason for all that fuss. Its job is way more complex than just, holding liquid. The best way to think about it is like a Swiss Army knife. Its main job, the most obvious one, is, to store the hydraulic oil. But it's also designed to be a radiator, getting rid of all that heat from the fluid as it's working hard. And this is the part that might surprise you. It's also a super sophisticated air separator. It's constantly working to pull tiny, really destructive air bubbles out of the oil. Okay, so let's really break down these big jobs. Every single hydraulic tank out there has 3 primary missions, and it has to nail every single one of them perfectly for the machine to even operate correctly. These are, like, the fundamental reasons this tank even exists. 3. That's the magic number. Every tank has 3 critical, you could even say non-negotiable functions. And get this, if even one of these fails, you're looking at potentially damaging the entire very, very expensive hydraulic system. So, what are they? Okay, here we go. Number 1, it stores the oil. Pretty straightforward, right? It just needs to hold enough fluid to supply the whole system. Number 2, it removes heat. Think about it, as that oil gets pumped under insane pressure, it gets super hot. The tank's large surface area is basically a giant radiator, helping to cool it all down. And number 3, it separates out the air. Air bubbles in hydraulic fluid are an absolute disaster. They make the controls feel spongy and can seriously damage the pumps. The tank is specifically designed to let all that air escape. All right, now for the really fun part. Let's imagine we can just pop the lid off this thing and take a tour of the inside. We're going to see exactly how engineers use some really simple-looking parts to pull off those 3 critical missions we just talked about. So first up, you've got the sight glass. Super simple. It's basically the dipstick for the hydraulic system. One quick glance, and the operator knows if the oil level is good. And here's a great pro tip right from the service manual. You always check it when the oil is cold. Why? Well, when oil heats up, it expands. So if you check it hot, you're going to get a false high reading. Simple, but crucial. Next up, we have the filler screen. Think of this as the system's bodyguard, its first line of defense. When you pop that cap to add more oil, this little mesh screen is what stops all the big junk, dirt, dust, maybe a random leaf, from getting inside the tank. It's such a simple part, but it's absolutely vital for preventing contamination. Okay, picture this. You've got a giant excavator bouncing around on some rough, uneven ground. What do you think is happening to the oil inside that tank? Yeah, it's sloshing around like crazy. And all that violent movement can churn air right into the oil, creating foam. And as we've already said, foamy, airy oil is a huge problem. So, how do engineers fix this? The solution is just brilliantly simple. It's these things called baffles. Basically, they're just internal walls inside the tank that act like wave breakers you'd see in a harbor. They break up all that sloshing and keep the oil nice and calm. But they do something else really clever too. They force the oil that's returning to the tank to take a longer, winding path. This gives any trapped air bubbles more time to rise up to the surface and escape before the oil gets sucked back into the system. It's just so smart. Now, it's super important to know that not all tanks are built the same. There are really 2 main design philosophies for how to get the oil out of the tank and into the pump. You've got vented tanks and pressurized tanks, and they solve the exact same problem in 2 completely different ways.
Okay, so the vented tank is the simpler design of the two. It has a breather, which is just a little cap that lets air in and out, so the tank is always at the same pressure as the air around us, atmospheric pressure. Here, gravity and the weight of the atmosphere just sitting on top of the oil are what help push it into the pump. Simple enough. But a pressurized tank, that's a whole different beast. It's completely sealed off. As the machine runs and the oil heats up, it expands, and that expansion compresses the air that's trapped at the top of the tank. This trapped pressure then actively forces the oil into the system. It's definitely more complex, but a lot of the time it's a more effective design.
So you might be wondering, how does a mechanic or a technician looking at some super complex hydraulic diagram know instantly which type of tank they're dealing with? Well, they use a simple, universal visual language. They're called ISO symbols, and it's basically a brilliant engineering shorthand.
And the symbol for a vented tank really couldn't be more obvious. It's just a box with an open top. It's visually telling you, hey, this tank is open to the atmosphere. It's simple, it's clean, and you just can't misinterpret it.
And you guessed it, following that exact same logic, the symbol for a pressurized tank is a completely closed box. It instantly tells you this is a sealed, closed system, totally cut off from the outside air. It's just a perfect example of how elegant visual communication can be in engineering.
So, okay, we've looked at its jobs, we've toured the inside, we've even learned the different design types. Let's bring this all home and tie it all together. Let's answer that big question. Why does this seemingly boring metal box matter so much to how a 100-ton machine works and for how long it's going to last?
When you boil it all down, a well-designed tank is doing an incredible amount of work behind the scenes. By keeping that oil clean, keeping it cool, and keeping it free of air, it guarantees that the machine has smooth, consistent, reliable power. It's kind of like the heart and the lungs for the entire hydraulic system, protecting all those expensive parts and really extending the life of the machine.
You know, there's a quote from the source material that I just love. It says that understanding a single component, its function, its operation, is what lets you break down complex circuits into simple ones. And that just nails it, right? By really getting how one part, like the tank, works, you suddenly have the key to understanding the entire, incredibly complex system. That's what it's all about for troubleshooting and maintenance.
And that really just leaves us with one final thought. This whole deep dive came from just taking a closer look at a common, everyday metal box. And it makes you wonder, doesn't it? What other simple-looking parts are out there, all around us, just hiding some truly incredible and elegant engineering?